Assalamu alaikum everyone. So today we are going to do alternative to practical and it's for 0620 paper 62. It's the latest one which is of February March 2025. Okay. So let's start with question number 1. If you see, you can see the diagram that it's related to the chromatography. Inks contain different colored substances called dyes. A student used chromatography to investigate the colored dyes contained in 6 different inks. The student drew a baseline on a sheet of chromatography paper. The student then placed a spot of each ink on the chromatography paper and set up the apparatus as shown in figure 1.1. The student made 2 errors. So they have mentioned that there are 2 errors. Identify the 2 errors that student made. So if you look at this diagram, the one error over here, you can easily figure out that there is a water. And if you see the water is below the chromatography paper, the chromatography paper is not dipped in water. So water level must be like this over here, that some of the chromatography paper must be dipped in the water and it is always dipped in such a way that the level of water is always below the baseline. But over here, the water is not dipped in the chromatography paper. Yes, very good, Saud. And the second error is that if you see all the spots, these spots must be present on the baseline like this, and these are not present on the baseline. So these are the 2 errors which we have identified in this. So the first error, that the chromatography paper is not dipped in water. And secondly, the spots are not placed on baseline. I hope both the errors are clear to all of you. Now, next part, state the name of the equipment used to draw baseline on chromatography paper. So I hope that you all know that when we draw the baseline is always drawn with the help of pencil, because pencil doesn't dissolve in any solvent, and when the solvent soaks up the chromatography paper and travels upward, so all the spots do travel upward along with the solvent, but the baseline doesn't, because the baseline is insoluble in the solvent. Is it clear to all of you? Now part C. The student corrects the error and then carries out the chromatography. The chromatogram in figure 1.2 shows the student's result. Okay. Identify an ink which could contain only one color dye. So the ink which is going to have only one spot on the chromatography paper. So if you see, that is the yellow ink, as yellow ink has only one spot. Very good, Saud. So we are going to mention over here that it's a yellow ink. Now, part C2, deduce which ink could be mixed with blue ink to make the black ink. So if you see, the black ink has these 3 spots, and if you see over here, that blue ink is have a same spot and the orange ink has the same spots. Okay, Marwa, I will share the paper. Yes, Miral, very good. So see, yeah, not just yellow ink, they identify an ink which could only one color dye. So see, they are asking for an ink. So it can be blue, it can be yellow, because both has one uh, spot. So both can be the answer. Is this clear? Yes, you can write. You can write blue ink or you can write yellow ink. Both are correct. Okay. Now, In the part 2, they are asking deduce which ink could be mixed with the blue ink to make black ink. So see, black ink, if you look over here, that black ink has these three spots. And if you see, blue ink has exactly the same spot. And then orange ink has those two spots. So it can be a combination of orange and blue, or it can be a combination of green. No, we can't use green and purple because see, the purple and the green both has the same spots overlapping with each other, right? Yes, we can go for a purple and the yellow ink. That can be correct answer. Or we can go with the other option would be that we can go with the blue and orange. Okay. So any one possibility can be considered as correct. So you can go with yellow and purple, or you can go with blue and orange. Oh, yes. Very good, Saud. So see, we can't go for a purple one because they are saying, yes, Saud is highlighted this thing, that which ink could be mixed with the blue ink to make the black ink. So one is going to be the blue ink. So with the blue ink, you can't mix the purple and the yellow inks, right? So with the blue ink, you can only mix the orange ink to make the black ink. So along with the blue, the other ink is going to be the orange ink. Is this clear? Now next part, deduce the color of one dye that is contained in all three orange, green and black inks. So if you see, they are asking for orange, green and black inks. So if you see, here we have the spot of the orange ink. Here we have the spots of green ink. And over here, all the three, black, green and orange, all three are present with the, oh, are at the same distance as the yellow ink. So the yellow is the correct answer. So yellow is the ink which is present in orange ink, which is present in green ink, which is present in black ink. There is no other ink which is present in all three inks. So the answer would be yellow over here. Is this clear to all of you? Okay, Nabiya, they are asking that you have to identify only a one ink. That ink is present in orange, green, and black inks. So if you see, green ink has this spot, so do the black ink as well. But orange ink doesn't have this spot over here. So it means, see, green contains blue and the purple are overlapping with this, but there is a no orange ink over there in this region. So we can exclude blue and purple to be present in all three dyes, all three inks. Is this clear, Nabiha? So if you see that spot on the top, so that spot is present in orange, that spot is present in green, and that spot is present in black. That spot is present in all three dip inks, and that is the spot of actually the yellow ink, right? So that is the one spot, one ink that is yellow, which is present in the orange ink. which is present in the green ink and which is present in the black ink, because they travel, the spots are at the same distance, indicating that this spot is of a yellow ink. So yellow ink is the one which is present in all three dyes. Is this clear? Okay. Now, question number 2. A student investigates the temperature change when aqueous copper 2 sulfate reacts separately with two different metals, zinc and iron. Okay. The student does two experiments. Experiment 1. Use 50 centimeter cube of cylinder to pour 30 centimeter cube of aqueous copper 2 sulfate into a 100 centimeter cube beaker. Use a thermometer to measure the temperature of the content of the beaker. This is the temperature at time is equals to 0. Add 3 grams of zinc powder to the beaker. At the same time, start a stopwatch. Using a thermometer, continually stir the mixture in the beaker. Measure the temperature of the mixture every 30 seconds for 210 seconds. Empty and rinse the beaker with the distilled water. The whole method is understandable to all of you. If any one of you has any confusion in it, please ask. Okay, now in experiment 2, repeat experiment 1 using 3 gram of iron powder instead of 3 gram of zinc powder. So then the experiment has been repeated using the 3. Now the 3 gram of iron has been used. Okay. Now A part, complete table 2.1 using the thermometer diagrams and calculating the temperature changes, that is delta T. Change in temperature is always going to be is equals to final temperature minus initial temperature from the temperature at 0 degrees Celsius at 0 seconds. So it's the initial temperature. Okay. So if we start that when the time is 30 seconds, if you record the temperature, it is actually 33.5. Yes. So you are going to subtract this temperature from the temperature at 0 degrees Celsius, which is 24. So 33 minus 20, 33.5 minus 24 is going to be 9.5. Then at 60 seconds, if you see, the temperature is 38. So 24, 38. Okay, do remember, if it's 38, you are going to put 38.0. Don't just write 38. So 38 minus 24, it is going to be 14.0. Yes. Then at 90 seconds, if you see, the temperature is 41.5. So subtracting 24 from 41.5, is it 17.5? Okay, thank you, so and Marwa. Okay, now at 120 seconds, if you see the temperature, it's 43. So the difference is 19. Then at 150 seconds, it's 45. So 45 minus 24, is it 21? Then at 180 seconds, it starts to fall again, right? And it is 43 again. Yeah, sorry. Thank you. It's 44. So the change is 20. Then 43, change is 19. And then it's 42. So change is 18. And see, you have to put the 1 decimal place for the temperature, not just 44 or 20. Keep this in mind. Okay. Is this clear to all of you? Okay. So that is for experiment 1, which means that is when we have added the zinc. Now when you have added the iron. Now, if you see, initial temperature is 20 and over, okay, it's 22. So over here we are getting 24.0, right? So the change in temperature is 2.0. Then if you see, it's 25.5. So the change in temperature is 3.5. Then if you see, now it is 27. So the change in temperature is 5.0. Then if you see, it's 28. So the change in temperature is 6.0, because we are subtracting this temperature from the 22. Now, if you see over here, it is 28.5. So 28.5 minus 22 is going to be 6.5. And then it's 29. So when the final temperature that we have recorded is 29, so 29 minus 22 is 7.0. Then again it's 29. So the change in temperature is again 7.0. Is this clear to all of you? Okay. Now, next part. Part B. Complete a suitable scale on y-axis and plot your results for experiment 1 and experiment 2 on figure 2.1. The point at 0.0 has been plotted for you. Okay. Draw two curve of best fit. Both curves must start from 0, 0 coordinates. Label both curves. Okay. So we are going to draw the two curves. So we have to start plotting the. Okay, so over here we have a time in seconds, and over here on y-axis, on x-axis, we have a time in seconds. That is change in temperature delta T. It means on on y-axis we are going to use the second column, and if you see in the second column, the maximum increase in temperature is 20, right? That is for zinc, and for iron the maximum temperature increase is 7. So we are just taking the increase in temperature. So if I take it 5.0, 10.0, 15.0, 20.0, and 25.0. So it means that the two small boxes are equal to 1 degrees, right? So at 30 seconds, now we are doing for the experiment 1. At 30 seconds, the change in temperature is 9.5. So 30 is over here, and it's 9.5. So 9.5 is going to be this point. Okay, keep in mind you are going to plot all the points with the crosses, okay? And then 60, it's 14. So 60 is this one. And it's a 14, right? Yeah, one small box is 0.5 degrees, or two small boxes 1 degree. Okay. Then at 90, it's 17.5. So it's 90, and it's 17.5. 90, 16. So 17.5 is going to be over here, right? Then at 120, it's 19. So 120 is over here, and if it's 19, so it is going to be over here. Then at 150, it's 20. So it is going to be like this. And then 180, it's 19. 180. it's 19, right? And then at 210, it's 18. So 210 is over here. And if it's 18, it is going to be like this. Is this clear? Now, uh, okay. So they ask for to draw a curve of best fit. So the curve of best fit is going to be like this. My curve is relatively a rough one. So it would be like this. Now, for the second one, at 30, it's 2. So if it's 30, it's 2, it is going to be over here. Then 3.5 at 60. So 3.5. And then at 90, it's 5. And then at 120, it's 6. So 120, it's 6. Then 150, it's 6.5. 6.5 must be like this. And then at 180, it's 7. So 180, it's 7. And then 210, it's 7 again. So again, the curve of best fit is going to be like this. Is this clear to all of you? So you are going to label this curve as experiment 1 and label this curve as experiment 2. Okay. Now, what they are saying, extrapolate the curve for experiment 1 on your graph in figure 2.1 to reduce the temperature change since time is equals to 0 degrees Celsius in experiment 1 after 240 seconds. Okay. Show clearly on figure 2.1 how you worked out your answer. Okay. So if I extrapolate it, so that is going to be 240. So that is the temperature. And if you see, it is 16 degrees, right? Yes, sir. So it is 16. So the change in temperature is 16.0. Now, state which experiment 1 or experiment 2 is more exothermic. Explain your answer. Yes, if we see, we can easily identify. Yes, but you can keep it as a curve. because it's a extrapolate, because it is in the form of curve. So you extend that curve to the maximum and then look at point 240. So we can see that in experiment one, the temperature changes 20. There is a so much energy has been released in experiment one. Miral, is your confusion? Did you understand that or not? Okay. So yeah, you can make the straight line, but it's better to show with the dashed line because it is not actually the curve, right? So it's better to show with the dashes the extra work you do. Okay. So experiment one is more exothermic, and as it releases more heat, and how could we identify that more heat is released? Because the change in temperature is greater in experiment one. Is this clear to all of you? Okay, now next part. Predict the temperature of the solution in experiment one after 3 hours. So see, sometimes the student get confused with this. They are asking for the temperature. So in experiment one, so the temperature would be that 24, that is the initial temperature, plus whatever the change in temperature. So we have to see that at 3 hours what happens. So 3 hours has how many minutes? So see, 240 minutes, 240, okay, it's a 240 seconds. So obviously it is again falling to the room temperature. Yeah, that is the second. So it's a 240 seconds. So again, it is falling to the room temperature. So so and what the room temperature that we have noted down for this, that is 24 degrees Celsius. So obviously after 3 hours, the temperature fall back to 24 degrees Celsius. Is this clear to all of you? Now explain why using a copper container instead of the beaker would not be an improvement in this investigation. Yes, who can answer this? If we use the copper container, it would not be an improvement. No, copper is not reactive. Yes, but the copper is a conductor of heat and electricity. So copper absorbs heat. So as a result, the heat lost to the copper container. But as you see, beaker is of a glass and glass are insulators, so they would not absorb the heat. So copper absorbs heat as it is conductor. So some of the heat is lost. So that's why we can't use the copper container. Okay. Now, describe two changes to the apparatus that will improve the results of this investigation. For each change, explain why it will improve the results. Yes, who can identify the change in apparatus? That what apparatus must be changed and what will be the result, that how it, that new apparatus will help us to get the improved results. Yes, anyone? Yes, very good. Saud. So I got one uh, method for one instrument, one apparatus from Saud. Now, can anyone tell me any other apparatus? So that is the same thing, Saud. That is the same thing. We have already preventing the heat loss from the conduction. How water bath can help you to get the good results? So one change would be that use the lid to cover the beaker, and as a result, less heat loss. It will leads to less heat loss. Is this understandable to all of you? Okay. So if you go through the method again, we are using the measuring cylinder to pour 30 centimeter cube of aqueous copper to sulfate. Actually, the objective of the experiment is to investigate the temperature change when aqueous copper to sulfate react separately. Okay. So you have to find the change in temperature, right? So using a 50 centimeter cube to pour 30 centimeter cube of, no, there is no pipette of 30 centimeter cube. So use a thermometer to measure the temperature of the contents of the beaker. Temperature at time. This is the temperature at time. Okay. 3 gram of zinc is powder is added to a beaker. At the same time, start a stopwatch. Using a thermometer, continuously stir the mixture in the beaker. Using the temperature of the mixture every 30 seconds for 210 seconds. Empty and rinse the beaker with the. Yes. Mm. No, there is no gas has been formed. There is only a displacement reaction. So So the second change would be, because we know that the when we use, yes, Marwa, very good. We can use a burette in the step one, because burette can use to record any volume in between 0 centimeter cube till 50 centimeter cube. And the uh, measuring cylinder that we use, it gives you the approximate results. It measures the volume approximately. So using a burette, volume of the solution is more accurate. Okay, beside this, you can use another thing. We are using the, if you see, we are using the thermometer of a least count of 1 degree, right? So instead of this, if we can use a digital thermometer, and digital thermometer can give us to the temperature change like not just 21.5. Yes, you can say the more graduated thermometer, Miral, or beside this, you can use a digital thermometer, which will be obviously more graduated. So we'll get the more accurate change in temperature. So more, and the explanation would be more accurate change in temperature. And obviously, if the change in temperature is more accurate, then it is going to be more, the result is improved. Now, question number 3. A student tests two substances, solution A and solid B. Test on solution A. Solution A is aqueous chromium 3 chloride. So they have already told you that it contains a chromium 3 positive ions and the chloride negative ion. Okay. A student divides the solution A into 3 approximately equal portions. Complete the expected observation. The first portion of a solution A, student adds aqueous sodium hydroxide dropwise until it is in excess. So if you see with the chromium 3 positive ions, see over here, where are the cations? Yes. Chromium 3 positive ions added sodium hydroxide, we will get green precipitates, and when it comes excess, it is it stays soluble. It is soluble in excess, which means it dissolves, right? So we are going to write green precipitates become soluble in excess of aqueous sodium hydroxide. Now, next part. To the second portion of solution A, the student adds 1 centimeter cube of dilute nitric acid followed by few drops of aqueous barium nitrate. So if you see, the dilute nitric acid is the test for the carbonates. If there is a carbonate, you are going to observe the fizzing. Dilute nitric acid and barium nitrate, you get the white precipitates when which ion is present? Sulfate ion is present. Yeah, you can write it dissolves. The green precipitates forms which dissolves or which disappears to give a clear solution. That can also be written. So yeah, no change over here because sulfate is not there. We have a chloride over here, right? So no change. Is this clear to all of you? Now, C part. To the third portion of solution A, student adds 1 centimeter cube of dilute nitric acid followed by a few drops of aqueous silver nitrate. So silver nitrate will give you the white precipitates. Very good, Marwa. So you are going to get the white precipitates. You need to remember these colors of the precipitates for paper 1 and the paper, the theory paper and the MCQs. But for alternative to practical, there is no need to remember these colors of the precipitate because these are given at the end. So see over here. For chloride, adding dilute nitric acid and silver nitrate gives you white precipitates. Okay. So we are done with this. Now, test on solid B. Table 3.1 shows the test and the student observations for solid B. Carry out a flame test on solid B, red colored flame. So if we are getting the red colored flame, so if we go through the flames, so it can be lithium, right? And there is a very light chance or less chance of being calcium ion as well. But they just specified red. So let's assume it that over here, what we have concluded that it has a lithium ion. Now, dissolve the remaining solid B in distilled water to form solution B. Divide solution B into three portions. The first portion of a solution B, add a few drops of acidified potassium magnate, pale purple solution. So when we add a few drops and the solution goes pale purple, so it means that the purple color actually diffuses, so the color becomes lighter, but no reaction occur. So over here, the pale purple color means that there is a no change. And if there is no change, so there is no sulfite over here because that test is for a sulfite ion, if I'm not wrong, that is SO3 2 negative. See, for SO3 2 negative, aqueous potassium magnate, it goes from purple to colorless, but it goes from, yeah, potassium magnate is always dark purple. So when it is being added in the solution, which is a colorless, and you are adding just few drops, and if the reaction would not occur, so the whole solution goes pale purple. And if the reaction occur, so that the on adding the few drops, that the purple color just disappears. Okay. So no change, it means no sulfite ion is present. Now, test 3. To the second portion of solution B, add about 1 centimeter cube of sodium hydroxide. Solution remains colorless. So it means the cations which are mentioned, no, if there is aluminum or zinc, you get the white precipitates initially, and in excess they dissolve, excess of sodium hydroxide. So it means no cation over there that are mentioned in the colors of the precipitate except ammonium. There would be no cation, but there might chance of ammonium. But for that we have to check whether the ammonia liberated or not. So test 4, warm the product of the test 3 and test any gases given off with the damp red litmus paper. Damp red litmus paper remains red. So if it remains red, so it means no ammonia is produced. And if no ammonia is liberated or produced, so it clearly indicates no ammonium ion is there in the solid B. Is this clear? Now, to the third portion of solution B, add 1 centimeter cube of dilute nitric acid followed by few drops of barium nitrate white precipitate. So that was the test for sulfate ions. So we got to know that sulfate ions are present. Now they are asking, uh, describe how to carry out the flame test used in the test 1. So take, it's a solid, it's not a solution, right? So take a small powdered B on wire loop, place it in blue flame and observe the color of the flame, which they have already observed, that is red. Now, identify the ion that is tested for in test 4. So in test 4, which ion have been tested? The ammonium ion have been tested, and we haven't found ammonium ion in this solid B. Is this clear? Yes, then you don't need, if they have, if that is a solution and you need to perform the flame test, so you just write, instead of this, you just write, put the wire in the solution for a few minutes or for some time, and then take out and place it in the blue flame. Okay. For nitrate ions along with sodium hydroxide, we add aluminium and then heat it, and we haven't added aluminium in test 4. Okay. Now, identify the two ions which are in solid B. So what ions we have identified? We have identified that there is a lithium ion first, and the second ion that we have identified, that is a sulfate ion. So lithium ion and a sulfate ion. Is this clear to all of you? Now, We are going to the last question, and in this, the last question is really easy. A metal spoons can be electroplated in the with silver. Describe how a metal spoon can be electroplated with the silver. Include in your answer how you could determine the mass of silver electroplated on the metal spoon. You are provided with the solid silver nitrate, a metal spoon, a piece of solid silver, distilled water, and the common laboratory apparatus. Okay. So first, what you are going to do? You are going to dissolve solid silver nitrate in distilled water to form a solution. And that is a silver nitrate solution which acts as an electrolyte, right? And over here in the bracket, you can mention that it's an electrolyte. Example, you can use a 250 centimeter cube beaker because it's a big enough beaker in which we can place or hang both the electrodes. Okay. Now, see, there is one important thing over here. You could determine the mass of silver electroplated on the metal spoon. So for that, what you are going to do, remember, you can't take this. You can do in either way. You can wait and record the mass of the spoon before the electrolysis, and then you can, after take electrolysis, you can take it out, and after drying, you can take the mass of the spoon again, and then take the difference. It will help you to identify, to determine the mass of the silver deposited on metal spoon. Okay. Yes, very good. So now weigh and record the mass of metal spoon. Now what you are going to do, connect the solid silver. We are going to make it at anode. Yeah, very good, Mariam. So solid silver at, and anode is the positive terminal of the battery, right? Positive terminal of the battery. Yes. Yes, Miral, you have to mention that. And metal spoon at negative terminal of the battery using wires. Now dip both solid silver and metal spoon in silver nitrate solution present in beaker. After electrolysis is completed, remove the metal spoon, dry it, weigh, and record its mass. Now, mass of silver electroplated. Now, you are going to just write the expression at the end. Mass of silver electroplated on spoon is identified by mass of spoon before electrolysis minus, sorry, mass of spoon after electrolysis, because after the electrolysis it has a greater mass. Mass of spoon before electrolysis. So that is how you grab the last question. And this one is really easy. And it's from February, March 2025. So I hope every one of you have understood. If any one of you has any confusion in this paper, please ask me. Yeah, if we have a something that is solid and that we have to weigh it, so whenever you remove it from the aqueous solution or the liquid, uh, we will then dry it. Obviously, before recording its mass, okay?